My name is Isabella Weiner, and I'm from Melbourne, Florida, in the US, and I built a Sulfur-Concrete 3D printer for building homes on Mars. On Mars, we're going to need some way to build, and since it would be really costly and inefficient to have to shuttle materials up from Earth, the best way to do that is by using resources already there, which is known as in situ resource utilization. So I've been doing my research with sulfur concrete. Regular concrete is made with aggregate, which is just crushed rocks, water, a valuable resource, and cement, which isn't available on Mars. However, sulfur concrete only requires aggregate and sulfur, both available on Mars, heated and mixed together. So over the years, I've looked into how best to make the sulfur concrete, testing strength with different aggregates and amounts of iron, and I even did compressive strength testing to find that it's just as strong as high-strength Portland concrete. So then I decided to come up with a way to actually use the sulfur concrete to build, and I chose additive manufacturing, which is basically just 3D printing material layer by layer. And there are actually several companies here on Earth working on 3D printing regular concrete homes. So last year, I designed a system for additive manufacturing on Mars, which I call SAM. SAM is composed of a gantry system with movement in the X, Y, and Z axes, a control system attached to a microcontroller I can program with my laptop, and a very simple extrusion system that was basically just using a big funnel totally reliant on gravity. However, this year I wanted to improve that extrusion system because on Mars there is different gravity and there's also a lot colder temperatures. So I wanted to incorporate a heated reservoir and heated tape around the tubing to be able to keep sulfur concrete heated and in a molten workable state. And I also wanted to add a peristaltic pump to be able to control the flow. So through a very iterative process with a total of 13 trials, I designed a heated peristaltic extrusion system, and I attached it to the SAM gantry system and was able to extrude the sulfur concrete along a 20-centimeter wall, which demonstrated the effectiveness of SAM as an early prototype for construction on Mars and the effectiveness of the peristaltic system with sulfur concrete.